All right, Algebra 1, this is page 148 in your book. Okay, we have like terms again, which are terms, if I can spell, forget that little scribble, terms with like parts. Okay, we have the distributive property. That's when you have a situation like this, 3 times x plus 2, and you multiply. Okay, that's a number or a letter times a sum or a difference, and that would equal 3x plus 6. Reciprocals are when you take a fraction and you flip them over. And what do you always get when you multiply a number and its reciprocal? You always get 1, because everything cancels out. 2's cancel out here, 3's cancel out, you always get 1. And that's important for one of the examples we're going to do. Okay, so first example, you're going to see it's a little bit different looking because the book was all messed up, so I had to redo them, so I apologize for that. This first example is solve an equation by combining like terms. So you'll notice here, we find the sides with the letter, and I see the 8x and the 3x, so I can simplify those. I need to start by simplifying those. So 8x minus 3x is 5x, minus 10 equals 20. Now that looks like problems you guys just solved in the last lesson. There's two things attached to the x, the 5 and the minus 10, so we add 10 to both sides. Those cancel out. 5x equals 30. We divide by 5. And in this case, x equals 6. Now to check our work, I know it's still long, but you should always check the original problem, which is this one up here. You shouldn't check here, because what if you made a mistake adding your like terms? You won't catch it. So you need to put it into the original problem. So let's just say it 8 times 6 up here. We're putting a 6 in right here. That's going to be a 6, and that's going to be a 6. 8 times 6 is 48, minus 3 times 6, which is 18, minus 10. 48 minus 18 is 30. 30 minus 10 is 20. It checks, and x equals 6. So there's example 1. Okay, now sometimes these are called multi-step equations. Sometimes one of the first steps is not only to add the like terms, but to get rid of the distributive property. Anytime you see parentheses in your equations where your x is, you need to distribute your number outside and get rid of the parentheses. So we just carry the 7x down. 2 times x is 2x. 2 times 6 is 12. That equals 39. So the first step was to do the distributive property. The second step in this problem is to see if we can simplify. Before we start adding or subtracting from both sides, we see if we can simplify. And I see a 7x and a 2x that will go together nicely. So that's going to be 9x plus 12 equals 39. And now we have equations like we just got done solving. We have that plus 12 will minus 12 from this side. 27 equals 9x. Divide by 9. X equals 3. So now put it up in the original equation. I won't read. 7 times 3 is 21. Plus 2 times 3 plus 6 is 9. 21 plus 9 is 18. And that makes 39. So we know x equals 2. So they're adding extra steps before we can do our solving. They're adding the like terms and the distributive property. Okay, example 3, this is a standardized test. It's at the top of page 149. I didn't put the whole thing down. Let's just, we can look through here. First off, step 1 is there's the equation. What are we going to do? Which equation is going to represent step 2 in the solution process? So right here, you're going to notice that here's the parentheses. We need to get, the first step is always to write the original problem down. So the second step would be to do the distributive property, which is to take this times this and this times this. But we have to be careful of this negative. We are distributing a negative 4, because if you were to boom boom that, it is a negative 4. So the first thing, we leave the 5x alone. Negative 4 times x is negative 4x. And negative 4 times negative 3 is positive 12. And that equals 17. So look through there with me. A is 5x minus 4x minus 12. That's not it. Look at D. 5x minus 4x plus 12 equals 17. So the second step would be D. That would be the correct one that you would now color in. Okay? And let me erase on this page. We'll do our guided practice together right here on this page. So here is the GP, the guided practice. Number 1. Okay, so just like you, we're writing the original problem down. 9D minus 2D plus 4 equals 32. And you might say, well, couldn't I just do the 9D and the 2D? I want the original problem written down so you can check it. So I got 9D minus 2D is 7D. Plus 4 equals 32. Just get used to writing stuff. I minus 4 first. That should be starting to get a little bit automatic for you guys to see that step. And if you don't, please ask. And D equals 4. Well, let's check it out. Let's put it up here. 9 times 4 is 36. Minus 2 times 4, which is 8. Plus 4. 36 minus 8 is 28. Plus 4 is 32. So X or D equals 4. All right, let me erase those. GP number 2, and you're writing it with me, is 2W plus 3 times the quantity W plus 4, and that equals 27. Okay, so the first thing is to do the distributive property. We'll leave that out there. So 3 times W is 3W, and 3 times 4 is 12. And I have like terms here, so let's simplify those first before we start trying to solve and get that W by itself. Now we have a plus 12, so we'll minus 12. 15 equals 5W. Oh, I just love writing. This is so awesome. W equals 3. See, one step leads to another. It's just step by step. You work your way down. That's some good stuff right there. So let's put in the 3 in the original problem. That would be 6 plus 3 times 3 plus 4 is 7. That's 21. 21 plus 6 is 27. It's worth the effort to check, especially when you're on a test. All right, let's think there's some more guided practice, which is awesome. That means we have more cool algebra to solve. We have 6x. Ooh, I'm glad they're doing one of these because we got to be really careful with that minus. 2 times x minus 5 equals 46. This is what I'm saying. When we have the distributive property, you see the parentheses, we have to do that first. But we're not just distributing in a 2, we're distributing in a negative 2. So negative 2 times x and negative 2 times negative 5. So I get 6x, negative 2 times x is negative 2x, negative 2 times negative 5 is positive 10. That's tough, very important right there. If you don't get those negatives right, it messes up the whole problem. 6x minus 2x is 4x, plus 10 equals 46, minus 10, 4x, those cancel out, equal 36. Divide by 4, and I want to see all of this. I want to see what x equals 9. Put it in up here. 6 times 9 is 54, minus 2 times 9 minus 5 is 4. That becomes an 8. 54 minus 8 is 46, so the answer is 9. Awesome. All right, the next example talks about using reciprocals. Okay, this problem, check out this problem. There are parentheses, but look at this. We have a 3/2. Sorry, I couldn't write the fraction the way I normally when I'm typing it in there. They have 3/2. I don't know about you guys, but I'm not really excited about multiplying with fractions. If this is the distributive property, you would have to take this times this, this times this. And then you'd have to come up with all these fractions. It'd be 3/2 times 3x would be 9 halves x plus 15 halves equals 24, and you'd have to minus 15 halves. Yuck. I don't like that. Let's not do. Let's do things the easier way. So what you can do, and this only works when you are multiplying on the outside by a fraction, and there's nothing else except the parentheses next to it. We can get rid of this 3/2 first, and you get rid of the 3/2 by multiplying by its reciprocal. Remember, think of the 3/2 being written this way. And if you multiply this side by the reciprocal, you still have to treat them equal. So you do have to go over here and multiply by a fraction. But look what happens. These cancel out, leaving you 3x plus 5 on this side. And we put that 24 over 1, and we cancel our 3 and our 24. 3 goes into 8. And negative 8 times 2 is negative 16. Look how nice that cleans up. You multiply by the reciprocal. Anytime you multiply, there is the distributive property and you have a fraction on the outside. Now check how easy this is. You just go minus 5 right here, minus 5, still being careful of the signs. And if you read it out loud, negative 16 minus 5, I would go boom, boom. That's negative 21. Divide by 3. X equals negative 7. And we can put it back in up here. Negative 7 times 20 is negative 21. Plus 5 is negative 16. Times 3/2. Cancel 8. 8 times 3 is 24. Negative 24. And it checks. So we'll do more of those in the guided practice, which is before this. So let's go back to that. Okay, so here's our, let me erase. This is GP number 4. Okay, so write the original problem. 3/4 times z minus 6 equals 12. Okay, now here's the situation, just like up here. We have a fraction, so we're going to multiply by the reciprocal. Multiply this side by the reciprocal. Those all cancel out, leaving you z minus 6 on this side. The 12 over 1, 3 goes into 3 once, 3 goes into 12 4 times. That comes out to be 16, and look how easy this is. Add 6 to this side, add 6 to this side, those cancel out. Z equals 22. Let's put it in. 22 minus 6 is 16, and I need 3/4 of 16. 16 over 1, 3 times 4 is 12, and that's what we started with. Takes a little practice. If you don't understand, please ask. It's very important that you take responsibility for these problems and understand how to do them. 2/5 times the quantity 3r plus 4 equals 10. So there's our distributive property. We don't want to distribute in a fraction, so we multiply by the reciprocal, times 5 over 2. Those cancel out. I get 3r plus 4 equals, put the 10 over 1, 2 goes into 2 once, 2 goes into 10, 5 equals 25. Now we just solve. Minus 4, cancel out. 3r equals 21. Divide by 3, r equals 7. If we were doing the distributive property with the fraction, we'd still be trying to figure out how to multiply those fractions. All right, the last one in this guided practice, which is number 6. The only thing they do to you on this one is they throw a negative at you. 4a minus 1 equals 28. No big deal, we still have the fraction. In this case, when you multiply by the reciprocal, just make sure it's negative, because we want those to cancel out and 2 negatives make a positive. So we would multiply this side by negative 5 over 4. And 4 goes into 4 once, 4 goes into 28 7 times. That's going to be negative 35 equals 4a minus 1. Add 1, add 1. 4a equals negative 34. Divide by 4. And sometimes it's ugly. Let's just reduce that. Let's divide them both by 2. Half of that's 17, and I think your book says negative 8.5. If you use a calculator, that's what you'll get. So we're looking at just recognizing when you can multiply by the reciprocal, and that really does make it a whole lot easier when you do that. Okay, example number 5. And back to what the book has. It's just a little bit easier to read. A flock of cranes migrates from Canada to Texas. The cranes take 14 days, 336 hours to travel 2,500 miles. The cranes fly at an average speed of 25 miles per hour. How many hours of the migration are the cranes not flying? Okay, so They go 25 miles per hour. They went 20, so let's put in the distance. I see distance. Distance equals rate times time. Their distance is 2,500 miles. Okay, their rate is 25 miles per hour. Well, that's distance, that's rate. And their time, they went 336 hours total minus their number of hours they flew. I think you just subtract right there. Their total hours we would subtract. So we're multiplying, so there's that distributed property right there. So you'd have 2,500 equals whatever 25 times 336 is, that's 8,400. I didn't do that, I cheated. Minus 25x, I looked in the book. And in this case we would solve, we got to get rid of the 8,400, so we minus 8,400. Remember, that's a positive 8,400, so the opposite is to subtract. Okay, and so 8,400 minus 2,500 is 0,095, 5,900. And it would be negative, divided by 25, negative 25. Two negatives make a positive. 236 hours they were not flying of that migration. They flew the rest of the time, up to 336 hours. Whew. Okay. So it says let x be the amount of time. There we are, writing our equation, doing our distributed property. I don't know why I write that all out. You guys can see that. Okay, suppose the cranes take 12 hours, 288 to travel the 2,500 miles. How many hours of this migration are they not flying? So basically, let's go back to this. It's 12 hours. You're doing the same thing, except, does it say 12? Let's go back to that problem. What's it say? They take 288 hours to travel, so you would go back to this, and right here we would put in 288, and we would do the distributed property, and we would go. I'll let you do that one on your own, and you're good to go. So solving your equations, multi-step. Please, once again, show your work. I know there'll be somebody who'll say, you didn't say that we were supposed to show our work. Yes, in the showing your work is writing the original problem first. Make sure you ask if you have any questions, and get back to the end. And that's it. We'll see ya. Bye.